students. Today we will be starting with next chapter of class 9th maths, that is factorization. So what is factorization? You have learned in arithmetic factorization before. Look at 15. We can write 15 as 5 into 3. We can write 15 as 5 into 3. Here we have expressed 15 as the product of two numbers 5 and 3. These two numbers 5 and 3 are factors of 15 and 5 into 3 is equal to 15. Here we have represented 15 as product of two of its factors. This is called factorization of 15. Now similarly, when we study factorization of algebraic expressions, we write an algebraic expression as a product of its two or more factors. Let us consider an algebraic expression. If we have x square plus 5x plus 6, x square plus 5x plus 6 is equal to x plus 3 into x plus 2. Here x square plus 5x plus 6 has been written as a product of two other expressions, x plus 3 and x plus 2, which are factors of this given expression. So factorization of x square plus 5x plus 6 is equal to the product of its two factors, that is x plus 3 and x plus 2. There are different methods for factorizing a given algebraic expression. We will learn those methods and then use them in solving the different questions. First method of factorizing an algebraic expression is taking out the common factor from the terms of the expression. We take out the factor which is common in all the terms and then that algebraic expression is factorized. Let us consider an expression 4a minus 8. This is a binomial containing two terms 4a and 8. We look for any factor which is common for 4a and 8. We look at the constants. 4 is a constant here, 8 is here. The common factor of 4 and 8 or HCF of 4 and 8 is 4. So we write it out 4. Then we put bracket because we have taken out common. Variable is present in only one term, so there is no need for checking the variable. 4 is already out. Now what will come inside? 4 is out, a is left. So we write a here minus 4 2s are 8. So we write 2 here. How we have reached this term is what we take out common. We have taken out common 4. So we divide the first term, that is 4a. 4a was divided by the common factor, that is 4. What is left? A was left. Similarly, minus 8 was divided by 4. What is left? Minus 2. So what we have written is a, that was the result here, and minus 2, that was the result here. 4 is common and what is left? A minus 2. 4a minus 8 has been expressed as product of two terms, that is 4 and a minus 2. So this is factorization of 4a minus 8 and this is the method for obtaining these terms. We divide each term by the common factor. Let us consider one more example to make it more clear. This will be 6a cube minus 3a square x plus 12a. Now look at this term. It consists of three terms. This expression consists of three terms. First is 6a cube minus 3a square x plus 12a. Now first look at constants. 6, 3 and 12. HCF of 6, 3 and 12 will be 3. So we take out 3 common here. But we can see that variable a is also common in this 3 terms, but the power of a is different in each term. In first term, the power of a is 3. In second term, power of a is 2. And in the third term, the power of a is 1. The HCF of a cube, a square and a is always the variable with lowest power. Lowest power is 1 here. So what will be common here? A. Now what is left? By the same method, 3 2s are 6, so 2 will be left. 1a is already out and it was a cube. So here a square will be left minus 3 1s are 3. A is already out, so only 1a is left now and x will remain as same because x is not taken out, plus 12a divided by 3a is 4. This is factorization of given expression. Let us consider one more example of the same type. 21 py square minus 56 py. Again, first step will be looking for the common factor in constants 21 and 56. The HCF of 21 and 56 will be 7. Look at the variables now, they contain more than one variable. P is here also and here also. P will be out. HCF of P and P will be P. Y square is here also and Y is here. Lower power of Y is 1, so Y will be out. Lower power will come out. That is the common factor, is lower power always. What is left now? 7 3s are 21. So 21 divided by 7 is 3. Py square divided by py will give us, p is already out, y square is divided by y is y, minus 7. 56 divided by 7 is 56 upon 7. We divide this term by this term. What is common? By that we divide the second term. 56 py upon minus 56 py upon 7 py. 7 8s are 56. Py and py cancel. What is left? Minus 8. So 21 py square minus 56 py. Factorization of this term gives us 7 py into 3y minus 8. That is, it has been expressed as product of two terms. This is first method of factorizing an algebraic expression, that is by taking out the common factor. The second method of factorization is grouping. If we have an algebraic expression containing even number of terms, then we can factorize that expression by grouping method. Let us consider one expression, AB plus BC plus AX plus CX. Now when we factorize such an expression, it contains 4 terms, that is even number of terms. We do grouping of terms in such a way that we get one common factor. We do grouping in such a way that we get a common factor. The grouping can be done either of the first 2 terms or first or third term. Accordingly, the condition is that we should get one common factor. Here, if I consider these 2 terms, if I do grouping of these 2 terms, AB and BC are taken in one group and AX and CX are taken in another group, then AB plus BC, in these 2, B is common. We take out B, and what will be left? Since B is out, A is left here and C will be left here. And in these 2, X is common. I take out X, and what is left? A plus C. On grouping the terms this way, we have got A plus C as a common factor. Now A plus C is contained in this term also and in this term also. So by taking out common factor method, we will reach to A plus C is common and B is left in this term and X is left in this term. This is factorization of the given expression, that was AB plus BC plus AX plus CX. This is known as grouping method. Let us consider one more example of the same type. X cube minus 3x square plus x minus 3. Again, it contains even number of terms, so we will do grouping to factorize the given expression. X cube minus 3x square plus x minus 3. Let us group these 2 terms together and these 2 together. In these 2 terms, x cube and x square, 2 powers of x are there, but the lower power is x square. So x square will be taken out as common factor because x square is out. X cube divided by x square gives us x, minus 3x square divided by x square will give us 3. In these 2 terms, nothing is common except 1. So 1 will be taken out as common factor, and what we reach is x minus 3. X minus 3 is present in both the terms. So x minus 3 is taken out as common factor, and this x square will be left in first term and 1 will be left in second term. So this is the factorization for given expression. Let us consider one more example. The question says as a square plus 1 upon a square plus 2 minus 5a minus 5 upon a. Recently we did the chapter expansions. This reminds us of one formula of expansions. What was the formula? A square plus 1 upon a square plus 2. This expansion was for the expression a plus 1 upon a whole square. So these three will be written as a plus 1 upon a whole square. Why we have written it? Because if I take minus 5 common from these two terms, minus 5 is common from these two terms, then what will be left? A will be left here. Minus 5a divided by minus 5 give me a, plus minus and minus, minus 5 upon a divided by minus 5 will give us plus 1 upon a. If I'll take minus 5 common here, we will get a plus 1 upon a. And here also, if I write it as a plus 1 upon a whole square, we will get a common factor in these two terms. So we have written it as a plus 1 upon a whole square using a formula from expansions chapter minus 5 into a plus 1 upon a. Now this is one term, this is another term, and a plus 1 upon a is common in these two terms. Taking out a plus 1 upon a, lower power, this power was 2, this power was no power, means power is 1. We have taken out that power, a plus 1 upon a. What is left here? A plus 1 upon a. One power will be left, minus 5. This is the factorization for this term. This was known as grouping method. This is what is grouping method of factorizing a given algebraic expression. Let us now study the third method of factorization expression, that is factorizing difference of two squares. We have learned in chapter of expansion that a plus b into a minus b is always equal to a square minus b square. So if we get any expression which is containing the difference of two squares like a square minus b square, then the factorization of this expression is always equal to a plus b into a minus b. For example, if we have an expression x square minus 25, here x square is a square term minus 25 is a perfect square and can be written as 5 square. It is a difference expression. This expression contains difference of two squares, x square minus 5 square. So factorization of this expression will be x plus 5, that is first term, plus second term, and x minus 5, that is the first term minus second term. These two are the factors of expression x square minus 5 square. Let us consider one more example. 150 minus 6a square is the given expression. We have to factorize it. Now neither 150 is a perfect square nor 6, but we see that 150 and 6 have 6 as their common factor. So first step will be taking out the common factor as per first method of factorization. We have taken out 6 as the common factor. What will be left then? 6 25s are 150. So 25 will be left here minus a square. 6a square divided by 6 is a square. Now the 6 is out, and again this 25 can be written as 5 square minus a square. Again this is of the form a square minus b square. So we can write it as 5 plus a into 5 minus a. So 150 minus 6a square has been expressed as product of three of its factors, that is 6, 5 plus a and 5 minus a. These we have learned three methods of factorization today. Practice the questions related to these methods and we'll learn the remaining methods next time. Thank you.